All right, cool. So we're recording. Let me share my screen. Does it look good?
Yeah, it's perfect. Week 5. Everything looks
All right,
good.
sounds good. All right, welcome everybody to week 5 of Free. My name is Gerardo Sanchez.
My name's Dakota.
And for this week, it's going to be talking about programming in electrical engineering. So there's just kind of 3 program languages that we're going to go over, which is C, Arduino code, and MATLAB. And we're going to go over some small demos at the end. So to start off, programming in C. This is one of the first languages that you're probably going to learn when you get into Long Beach. It's EE186. And what C is a procedural programming language. It was developed in 1972 by Dennis Ritchie, and it was mainly for developing and operating systems. Some of its main features of C is that it has low-level access to memory. It has really simple keywords. It has a very clean style, and it's pretty ideal for beginners to learn.
So a little bit into the structure of C programming. We have the header, which includes all the files.
Hold on, your mic sounds a little
Bad? Like, am I quiet
there,
or what?
there you go. That's better.
A little bit interference going on. So the header files is, how do I explain this? So it's gonna contain all the main. Anytime you write a programming project in C, you need a header file, and it's going to contain all the main code that you're going to use. So, for example, like if you can see on this little image right here, it says header, and then hashtag include, and then in these 2 arrow notations, it says stdio, which means standard input output stream.h, and you're going to have to include this anytime you write programming or write any code in C. There's more header files you have to include if you're going to go into a more complex like C++. But for C, mainly just have the standard input output stream. And then the next part that you have is the main, which is you can declare as integer main or void main, but this is the section of the code where all the body goes. You have everything the whole procedure that you're trying to do goes into main. And within main, you can have variable declarations. So for example, if your code includes some equations and you need variables, which most of the time you do, need integer variables, you can declare it as int space a and then declare the value of your variable. And then also inside main, you have the body, which is, like I said, contains all the functions and procedures that you have. One of the procedures you have is when your code is running, the program compiles your code, you can use printf with this parentheses, and then inside the quotations, you basically put what you are wanting to show up on the screen, and then comma A is, okay, so what's happening here is you're declaring A inside printf, so it's going to print out the value of A, and then you use %d for, in this case, because it's an integer. You would use %c if you declared A as a character, or you can also just type out what you want to print out inside the quotation marks. And then if you initially declared integer main, then you have to have a return value, and then return value would be 0. You can omit this part if you declare void main. So instead of int main, you just type out void, void main, and then that's the last part of the main body of your code.
Yeah, so this is pretty, I guess, simple like structure of the C programming code. But I guess as you get into it, you kind of see how it changes up. So instead of main, if you were making a special function to, let's say, I don't know, like kind of make a sine function or something like that, you would call it int sign or something different. So it really just depends on your function. This is just a simple structure right here. But next up we have programming in Arduino. Geez, sorry. Next up we have programming in Arduino. We have programming IDE. Uh, it's based off of C and C++, so it's pretty. If you start writing in C and then you start doing Arduino, you'll see it's kind of it's actually a lot simpler. There's a lot less in setting up your code and stuff, but you have the same conventions for variables, and you end lines with semicolons just as you do in C. But with Arduino, you have code continuously running. You can set up the code to only run once, but that wouldn't be ideal. You would want to use a loop to run the code continuously. And something different is that because with Arduino programming, you're connecting it to something physical, which is your Arduino board, you need to declare pinouts and declare whether those are inputs or outputs. So right here on the right, we have something pretty simple, which is just a blink. And you'll see that this is already kind of built into the Arduino program and already kind of can be easily integrated to your board without really having to do any connections or anything like that. So in the beginning, we have a void setup, then a pin mode, and we're just declaring the LED, the built-in one, as an output. And we have our void loop. And basically what's going to be running here is we're going to start off with a high LED, which basically means we're outputting high to the LED built in, which in return is just going to turn on the little light on your Arduino board. And then we have delay of 1,000, which is in milliseconds. So 1,000 milliseconds is just one regular second. And then you run the code of built-in LED low. So now we're outputting low into the LED built-in. So which is just going to turn off your LED. Then once again, we wait 1 second. And then because it's a loop, it's just going to go right back to the beginning. So it's just going to be blinking on and off, on and off.
So this just basically goes over the setup of Arduino. As you can, like Gerardo said, it's kind of based on C programming language. So you can see you have the first red box is void setup. This would be the same thing as where you declare your variables in C. So this has like pin mode. We declare LED as an output. So then the program's going to know when we talk about LED down here in the body, then it is an output. So it's going to know to send out information. And then always in void setup, you have serial dot begin, and then 9600. It's for the serial monitor. Basically, it's for the processor to know the speed to run the program. And then over here you have the void loop, which would be similar to the integer main or void main in C programming. And this is where you put the body of your program. So right here we digital write an LED high, and this would be LED was so this shouldn't be a built-in LED. Yeah, so we're declaring this is a variable LED. So it's going to serial print LED will turn on. This is the same as printf in C. And then like Gerardo said, the delay is 1 second. And then we digital write LED low, which then turns off LED. And you can see here, again, we output to the screen that the LED is going to turn off. And then 1 more second delay. And then this is a loop. So it basically just loops this over and over again with the 1 second delay turning on and off the LED. Let me see if I missed anything.
Oh, sorry about that.
No, I'm good. I'm good.
Yeah. All right. So last one is MATLAB. MATLAB is a matrix-based language allowing for natural expression of like computational mathematics. So it can get very simple where later on I'll just be showing like a very simple example of what you can do, what you can use MATLAB for, but it can get very complex. So some of the application is to do simple analyzing of data. You can develop algorithms and create models and applications. So the language, the apps, and the built-in math functions in MATLAB help you to quickly explore multiple approaches to different solutions. Multiple approaches to different to the same solution. So it really depends on kind of how you want to use MATLAB for. And MATLAB is structured very simple with only really variable declarations happening. And then you just have like simple operations to have your code running. So MATLAB is a lot simpler compared to C or Arduino, in which the setup is a lot. There's virtually no setup. You kind of just go in, you start declaring your variables, and you kind of start working with all like the operations and stuff that MATLAB has already built into it. So MATLAB is a lot easier in terms of the setup. You kind of just get right into it. And so that's basically it for like all the programming that you see in electrical engineering. I know it's like very brief, but you get a lot more into it when you take the classes. And but it's better to know kind of what's going to come up and what each one might be used for differently. So for example, MATLAB, we use, at least me personally, I use it a lot right now in my digital signal processing class and in my control systems class, just to analyze data and print out graphs and spectrograms and different stuff like that. So there's a lot of different applications, and you can even use MATLAB Simulink. I think Dakota uses Simulink in MATLAB, right? Or use LabVIEW actually, right?
Yeah, I use Simulink a
Oh,
lot.
Simulink.
Actually, I used it for my 350 class, basically simulating motors.
Yeah, so Simulink isn't, so it can get a little bit of programming, but it's more so just simulations of different models and stuff. But that's basically it for the presentation. Now we're gonna get into some demos. I don't know if you want to go first, Dakota, or
Yeah, I think that I should probably go first with the C because it's a little bit more basic, and I can't screen share that.
oh, let me see. Cool.
Full screen. Oh, okay, I don't want to share that. So not this one. This one's the second one. Okay, so this right here that you're seeing on my screen is a very basic C program. Um, it only includes, actually, it does include functions. So this, if you take 186 Intro to Programming, this is one of the programs that you kind of do to explore functions. So you can see I have all this top stuff is comments, and you can comment out in C by just doing double slash. And then right here is the header files I was talking about earlier. Um, so here I include standard input output stream like you always have to do anytime you're writing script in C. And then I also included math.h so that, where's it in here? This must be left over because I don't have any, I'm not running any functions. But so math.h I would include if I was typing in some type of equation. Um, so you can see here, and then I have my void pyramid, which I declare a function. And this is another key element of script programming in C. Functions kind of help you clean up your code and make it look a lot more simpler. As you can see in void main right now, the only thing I have is pyramid, which is a function. So this is really helpful when you have like really long script files, like hundreds of lines of code, and you want to make it more simpler, easy to read if you're working on a team, or even if you want to come back and look at it later again yourself. It's a lot simpler to just read, oh, okay, I have a function that does this. And then you usually want to name your function something similar to remind you of what process your function is trying to do. So here I made it a pyramid. And then when I went into the body of code, void main right here, it's everything in between this bracket and this bracket right here is the main body. And so the first line in the main, I typed in pyramid parentheses. So that what this does is calls the function. So now the code's going to jump down through the script till it finds that function. And so right here it finds the function, and then everything in this function is between this bracket and this bracket. And here all I did was, for basic purpose of showing how the function works, I used printf and basically drew out a pyramid with CSULB in the center, so that when I run, run, you can see basically how it works. So then at the end of the function, basically it closes out and then jumps back to this line or this next line after it's done doing the process in the function. And then this right here pauses the output screen. That way you can see actually what's happening without it going away. And I think Gerardo probably remembers doing this too. Let me see if I just run it. Yeah, so you can see right here. It's literally, I literally just typed out CSULB with a pyramid in it. And that's how you can see that exact printf, how exactly printf works. Whatever you put in the quotations is what ends up on your output. And I have one more, a little bit more complex. So you can see here, this program is closer to 75 lines of code, but I do the same thing here. This one's gonna output a matrix. So this gets a little bit more complicated. So what I have to do is I basically included all the same header files. Then in main, I'm not gonna explain every line of code, but what I do is I ask for user input. And the way I do that is use this function scan, and I scan for number input. And then it has to be a number. So I check if they're putting in something else, maybe by accident. And then if they don't put in a number, say they type in a character, I make them re-enter. And then this goes over a concept called a loop that Gerardo talked about earlier. So this loop would basically keep happening. It'll keep asking for input as long as this value, which is a condition I created to be 1, and it's always true if they're putting in the wrong input. So if they put in the correct input, it just breaks. That's kind of how a while loop works. You have a condition and an infinite condition unless you break out of it or meet the condition. There's another one called for loops where you designate how many times you want it to go through the same process. So then here I do another input, ask the user for input. So I ask them what number you want to, where was the first one? Oh yeah, so I want to start the number matrix with that number. So it's going to create basically a matrix counting from whatever number you put in up sequentially. Then I want to, for some reason, replace the number, any number in the matrix that's divisible by a certain number that the user wants to put in. So then I get that input. Then I ask you what number you want to replace, or what is the replacement number that you want to replace that new number that you're getting rid of. And then here I create a for loop like I was talking about to create the matrix. So I start from initial condition I is 0 to I is less than 6, and then this I plus plus means count 1 or increase I by 1. So then this loop is going to happen 6 times. And then I basically print out a matrix that I created. I won't get exactly into that, but you can see here I create a matrix, and then let me go ahead and run the output. You can see here it says enter a number I would like to start the matrix with. So let's say I just started with 1 for simplicity. Now the modulus number, any number that's going to be divisible by this number would be replaced. So let's say 2. And then I want to replace those numbers with a 5. So you can see here it counts from left to right across this row. This would be a 2, but 2 was divisible by 2, so it gets replaced by a 5. So you can see in the columns all the numbers divisible by 2 get replaced by 5. And kind of in this sense, C language is pretty diverse. You can do a lot of stuff. But if you're wanting to do something more complex, like analyzing graphs and data, then you wouldn't be using C. You'd be using something more like MATLAB that Gerardo can go over now. So let me stop screen sharing. Or did you want to add anything, or did I kind of go over all the main parts?
Well, I think it went over for the most part. I would say
Yeah.
just Some of the things you'll encounter the most in programming in C, especially like just 186, is gonna be like what Dakota was talking about, like the loops, like while loops, um, while loops, if statements, and like
For
what
loops
else?
case
For loops, do while loops. So do whiles are different from whiles, as in whiles will only run if there's like a specific what do you call it?
condition.
A specific condition is met. While do while loops, they're always going to run at least once, and then they kind of run afterwards only if that special condition is met. So that's the difference between a while loop and a do while loop. If statements are basically you just run it once, and if that, but you only run it if the argument is true. And like Dakota said, for loops are just kind of you run it for a specific amount of time. So that's basically what you're going to work with for the most part in C. We'll ask you the questions at the end, so just hold on a little bit. Not just ignoring the question, but just really quickly, just want to go over, I guess, some MATLAB stuff. So really here, I just want to show like a super simple example of like what you would be using MATLAB for. So in MATLAB, if you can see my mouse right here, you have all your folders, which are basically all your MATLAB files. On the right, you have something called a workspace, and here you're going to see later on that this basically stores our values and stuff like that, so our matrices and whatever it is that we may be working with. Here in the editor is where you would be having your entire script, but if you don't want to write a script and just want to kind of get right to it, just go over some quick stuff, you can do here a command window. So some quick example is, let's say we want to kind of print out a graph of like a sine graph or something like that. So let's say we create some vector time. And let's say we do from 0 to 1 second. And let's say we create some function y is equal to cosine of 2 times pi times our function, our variable t. So we can see here that we do have two outputs, but let's say we were to want to like plot that, and we just have t comma and then just y, which is our cosine. Let's say we plot that. It's just a straight line. So obviously this doesn't look anything like a cosine graph. So we gotta fix our code. So what we would want to do is create more points in our, because it's really just a vector between 0 to 1. So we'd want to create more points in between. So what I'm doing here is creating points from 0 to 1 with increments of 1/10. So if we go there, we see 0, then 0.1, 0.2, 0.3, 0.4, and so on up until we get to 1. So let's say we do, once again, cosine to update those values. And we can see we have a lot more points. And if we plot that, we can see we get
Oh,
a
your
much
graph
better.
doesn't pop up.
Oh, it doesn't pop
At
up?
least yeah, I can see it.
Let me see. Let me share my whole screen then. Is that better?
There, yeah, there we go.
Okay, cool. So yeah, so if you, it wasn't visible before, unfortunately, but because if we can see here that we just have 2 points and it's 1 and 1, so it's just going to go from 1 to 1. It's going to be a straight line, which, like I said, isn't very representative of what a cosine graph is supposed to look like, at least just one period from 0 to 2 pi, essentially. And what we see here is that we don't really we get something that looks like a cosine graph, but it's kind of choppy in between. So let's say we want a clearer image of that. Once again, we go into our time vector, but we create more points in between. So now we're doing with increments of 100. And let's say we do that with cosine. And similar to C, if you put a semicolon right here, it's just gonna block all that output from showing, so nothing really pops up anymore there. And if we plot this again, you see we get a much smoother graph right here of what a cosine graph is supposed to look like. So this is kind of a very simple introduction into what you can essentially be doing with MATLAB. Uh, so if I can show something here really quick. if I have 37 lab 1. So this is some very complicated, not complicated, it's very quite simple. Uh, what I'm doing here essentially is for lab work, and essentially in the beginning, we're just reading data that we took. In this case, the file name is on-off control variable.csv. So if we run this, we can see we get some stuff here. Let me see. This may not be it. Oh no, this is lab. I'm looking for. Give me 1 second. Well, yeah, so can't find exactly what I wanted to show right now, but that's a very simple example of what you can use MATLAB for. But what I was really trying to show after that was something that I did recently, which was creating a circuit for my control systems class, and essentially taking that data, and you take that data, you save it onto an Excel sheet, and you can take that data from your Excel sheet back onto to MATLAB, and you can do direct analysis of all your data that you have there on MATLAB. So for example, what I had there was a first order circuit. So it was just a resistor and capacitor really. And you just see this value go from 0 and you input 1 volt, and essentially your output is just, how would I say, it approaches the value of 1 very slowly, and just kind of looks very simple. But you take that data, you take it to MATLAB and you analyze it, and you do kind of whatever your professors are asking you to do with a certain data set. And that's basically what you use MATLAB for. And you can't really do that so much with C, so that's where it differs from C. And so yeah, that's basically all we have today for programming and engineering. We'll see you guys next week.